Okay, quiz 2, question number 3, which is on the trigo and bearing question. Okay, so I'm going to redraw this diagram over here so that you have a rough idea when I explain so how it looks like. Okay, so rough sketch over here. Okay, so this is north, this is 110 degrees, this is P, this is 9, this is 20, and this is Q, and this is 50, and of course this is point R. Okay, so first question. Okay, before even we talk about the first question, let's always remember to read the question and see any other information that's not shown on the diagram. You need to transfer down from the question. So basically they're saying that these are the three towns. PQR is on the horizontal ground, it's flat. Okay, so there's 20 kilometers away and 9 kilometers away, so it's indicated in the diagram. And there's a degree of 50 degrees and 110 degrees, both are indicated in the diagram. So okay, so it's all good. So A part 1, we are supposed to find angle PQR. So angle PQR, where is that? PQR is over here, this angle. So how do we find this angle over here? So if you look at the mark, it's just one mark. The mark will give us a clue how much work we need to do. So in this case, if it's just one mark, good chance that we apply one rule or one property or one formula, we can get the answer straight away. So if you have seen it, the formula that we need to use is actually sum of interior angle. Okay, because we have part of this angle 50 already. Okay, 50 is on the right side here. Okay, there's a 50 here. So therefore what we need to find is this angle. So how to find this angle? You can see that we have 110. So this is what we call the sum of interior angle. Okay, so A plus B is 180 degrees. We have two parallel lines. Okay, so basically, so angle PQN. Okay, let's label this as N1, this is N2. N2, so it will be 180 minus 110 equals to 70 degrees. So we can label this as angle in the interior angle. Okay, so therefore hence angle PQR will be equals to 70 plus 50. That will give us 120 degrees. No reason needed because it's just adding up the two angles. Okay, so this is A part 1. Okay, A part 2. Okay, so A part 2, let me just scroll down. Okay. So A part 2, we are supposed to find the area of PQR. So area of a triangle, PQR. So if you look at the triangle, so you have this triangle here, we have the 9, we have the 20, now we have this angle. So it's pretty straightforward, isn't it? So area will be half AB sine C. And half AB sine C, and to apply this, remember half AB sine C, any triangle with two sides A, B, the angle will be in the middle. Okay, if we have A, B here, A, B, and here, the angle must be in the middle. So it's always like this, your ABC. So in this case, we have the ABC, so just need to substitute in. Remember, whenever we do this, we must make sure that our calculator is in the correct mode. It must be in the degree mode. Remember, degree mode. Okay, so when we do radian, then we have to convert to radian mode. So normal, any others, we always keep it as degree mode. Okay, you have a D on top of the calculator. So once you plug in this value, you should get the 77.9422 ... For angles, oh no, this is area, so we round off to 3 significant figures. Just indicate as 3SF. Okay, so that is for part 2, A part 2. Part B, show the distance between P and R is approximately 25.7. Okay, so where is the PR? So if I were to sketch it out the diagram again, PR is over here. So the information we have this, we have 120. Okay, and we are supposed to find this value. And we actually have the area itself. Okay, so how do we do this? So we have 2 marks for that. Okay, so of course, to find the length, things that come to our mind will be Tuakaso or Pythagoras theorem, a square plus b square equals c square, sine rule, and of course cosine rule. Okay, so these are the 4 methods we can use to solve distance. Okay, but the first two, Pythagoras theorem and Tuakaso, this must be right angle. Must be a right angle triangle. Okay, so right angle triangle, then we can apply the Tuakaso and half AB sine a square plus b square is c square. So therefore in this case we can only apply the third or fourth, okay, because it's not a right angle triangle. So in this case, quite clear cut, because we don't have any pair. For sine rule, to apply sine rule, we must have a pair, meaning to say there's an angle and opposite length. Let's say 30 degrees and this is 5. We have one pair. Then we can find the next pair. Let's say 6. We want to find the angle. We can use another pair. So in this case, there's no pair per se. We don't know the angle opposite of 9. We don't know angle opposite of 20. We don't know the length opposite of 120. So the next thing we can do over here for this question is only cosine rule. So cosine rule will be a square equals to b square plus c square minus 2bc cosine a. Okay, so how do we do the a and b and the c? So for this triangle, okay, for any triangle, the angle is always the a. If let's say the angle is a, the one that's opposite of the angle a will be a length a, small a. The other two will be b and c. Okay, so in this case, our unknown would be our PR, which is the one that we are supposed to find. PR square equals to BC would be 9, B square would be 9 square, C would be 20 square, minus 2, 9 and 20, cosine 120. Okay, so once you put that in, PR would be, we just key in the calculator and we square root the value. So that would be okay, so basically we just square root this whole thing. We can just plug everything down inside. 20 square minus 2, 9 and cosine 120, and the answer will give us 25.709 ... equals to 25.7 kilometers. And this is supposed to show three-cific. Okay, so that's for part B. Okay, moving on. Next, part C question. So we are supposed to find the bearing of tau P from tau R. Okay, so let's take a look. Okay, the diagram, I redraw the diagram again. Okay, so this is north, so the P, Q and R. We want to find the bearing of tau P from R. So from means we need to draw a line over here, the north line. From R means we start from R, clockwise direction all the way until it touch the line PR, because this is the P and R is the one that is indicated. So this is the line that we need to look at. So draw the north line at R, because it's from R, clockwise direction towards here, and this is the bearing we are supposed to find. Okay, so how do we find the bearing of this? So one way I'm looking at, we can have many different ways, but one way I'm looking at is if you can find this angle in green color, we just use 360 minus this, let's say this is x lah, minus x. That will give us the bearing. Okay, of course we can do other method as well, but I think that might be a bit. Another way is, of course, let me use another color, highlight in light blue. Another way we can do it, of course, is if we have this 50, we can try to find this angle of this blue angle. Let this be y maybe. Okay, then after that, after y, then we need to minus away the small angle over here. Then we can then use 360 minus that will give us the answer. Okay, so now let's take a look at which method is easier. Okay, so this is for part C. Okay, so let's also recap what the information we have already have. So this is 25.7. Okay, the length 25.7. This is 9. This is 20. The angle that we have over here is 120. So this is also 70. This is 110. Okay, so now I think for this question we need to find one of these value. Okay, so let me highlight in green. The thing that we can find is, to use the first method, we need to find this small angle in highlighted in green. Once we found this angle, then we can find the top angle, then we can find our x. Okay, so I'm going to stick to that method and I'll try to solve that. Okay, so now first, so how do we solve this highlighted in green, the angle? So find angle RPQ, which is this angle. So how to find this first? So basically, to find this we need to use sine rule. Okay, why sine rule? I redraw that. You have 20, you have 120, we have 25.7, we have 9 here. So now we have a pair. What we need to do is to find this. I need this pair. Okay, so I put the unknown. Sine angle RPQ over 20 must be equal to sine 120 over 25.7. Okay, so then we can solve it. RPQ equals to sine 120 over 25.7 times 20. Then after that, RPQ we sine inverse. Whatever value here, we put it down, and the answer should give us 42.3543. More decimal place, because this is not the final answer. Okay, once you got that, next will be we need to use let me just confirm the score. So sine inverse, okay, sine 120 bracket divided by 25.7 times 20. Oh, 42 point. I have a slight different value for some reason. Okay, one thing that I want to highlight is we should be using the value that is shown. If let's say we already show in, let's say, part B, right? We want to show this. Once it's shown, we need to make use of the value that's shown over here, exact value, which is 25.7. We don't use the more accurate value anymore. Okay, so this is something important. Okay, I write it down, don't use 25.709. Okay, because once we prove that we showed something, we use back the value that is given. Okay, right, so therefore if we use this value, let me just erase this. Okay, it should be 3726. Okay, so this is the angle, the one highlighted in green. So to find the angle itself, so I'm going to use 110 degree minus 42.3726. That will give us 110 minus answer, which is 67.627. So this angle 3. So this angle here will be for this angle. Let me just bring it over, this angle. Okay, so once you got this angle, the next part we're going to do is basically use the sum of interior angle. 180 minus 67.6273. So 180 minus answer will give us 112.3726 dot dot dot. So this will be the angle X, the one in green. Okay, we need to write down interior angle. Then final part will be, so hence bearing, which is the final question, bearing of P from R will be equal to 360 minus 112.3726. So 360 minus answer will give you 247.627, and since it's bearing, angle will be given as 1 decimal place. That will be final answer. Okay, so that is for part C. This question a bit long. Okay, part D. Okay, so part D now is we're gonna do the 3D. Okay, so now an eagle is going above 3 kilometers above point Q. Okay, so calculate the greatest possible angle of depression. So if I were to draw it out, so it looks like this. So we are supposed to be above Q. So Q is over here. Q is over here. And we are supposed to find the greatest angle along PR. So along PR will be this. Okay, let me just. PR is this line. So there's a 3D figure coming out from here, and we want to find the greatest angle. So greatest angle is actually always the perpendicular distance, shortest distance from this point to this point. Okay, and there's a 3D line coming up, and you are supposed to find the angle over here. Okay, so if I were to redraw, let's say this is the top, I put as the top of the eagle rather. So if I will draw 2D, Q is at the bottom, the eagle is on top, and let's say this point over here is point Z. Okay, Z will be over the other side. So the angle we are supposed to find, this is right angle because it's right above Q. The angle we are supposed to find is the angle of depression. Angle of depression is actually this angle. This angle is actually also equals to the angle over here because of alternate angle. Okay, alternate angle, so you can see that this is alternate angle. So how do we find actually this angle here? Okay, so first thing first, we have the information. Let's fill out the information that we had for this. So this is 3 kilometers. And anything else that we know? In fact, we don't know anything else except for just these 3 kilometers, and this is right angle. So therefore, we need to find at least one more information. We want to find the information of this length QZ. Once we're able to find this QZ, then we can use the Tuakaso to find so this is number 1, find this length. Then second, then we find the angle. So how do we find the length? So QZ is actually from this diagram. This is Q here, this is Z here, this is 90 degrees because the shortest distance is perpendicular, always perpendicular to the point. Okay, let's say the point here, you want to go straight to the line is actually always straight down and is perpendicular to the line. No, and not anywhere else but perpendicular. Okay, so how do we find this information? So we have quite a fair bit of information over here. We have all the length, 25.7. We have the angle, we have this angle as well. Okay, so to zoom in to find the length of this length itself, which is the one over here in green. So what we can do is we can make use of the area, because if you look at A part 2 answer, area of a triangle, area of PQR, right? PQR, we found this. So we can make use of the area. We can use as half times base times height. Okay, because we can use this 25.7 as the base, and this is the height that we are supposed to find. Okay, so if we look through back again, the question number A part 2, the answer is this. So we're going to use the more significant value, 77.9422. Okay, so let's put it down. 77.4922. Is that correct? 4922? 9422, my bad. 9422 equals to half times our base, which is 25.7, times our height. So we can easily find the height. Okay, so by multiplying by dividing by half and divide by 25.7. So 77.9422 divided by 0.5 and then divide by 25.7. So that should give us the length of 6.0655. Okay, so that will be the height. So once we got this height, we transfer over here to get the angle. So now we have this triangle, the right angle triangle. We have 3 kilometers, and this is 6 kilometers, 6.0655, and we want to find the angle. So since this is a right angle triangle, we can use Tuakaso. How to use Tuakaso? This is the O, this is the A. So it's tangent theta equals to O over A. So tangent theta equals to O is 3 and A is 6.0655, and to find the angle will be tangent inverse 3 over 6.0655. So tangent inverse, okay, a fraction 3 divided by 6 answer bracket equals to 26.3168 dot dot and 26.3, one decimal place. Okay, so that will be the answer, and that's for this question. Right, very long question.